So thank you so much, Steve. I would like to just dive into your background and what sparked your interest in artificial intelligence first and foremost. We would love to hear about that.
Well, that sounds good. And thank you, Destiny and Mike, for having me. So I developed two interests during graduate school at Johns Hopkins: statistics, which is now called AI, and what was then called AI, but is very different from today's AI. At Towson University in the late 70s, I taught statistical techniques like classification and regression. It wasn't called AI back then, but most of today's amazing AI systems, including facial recognition, machine translation, speech recognition, and many others, use classification techniques. One of my first jobs was to use regression techniques to predict horse racing outcomes in 1979 for the top supplier of data to New York area bettors. Then, also in graduate school, my graduate school advisor was Bert Green, who in 1960 at MIT wrote a well-known AI program that answered natural language questions about the 1959 baseball season. How many times did the Yankees beat the Mets by more than 2 runs? Those kinds of questions. And then I met Roger Schank, who had one of the highest profile AI labs of its time at Yale University. And I ended up doing postdoctoral work at Yale and then helping Roger start an AI company in 1981.
Wow, that's absolutely fascinating. So tell me about this beginning as you started to use stats to help with sports. And I'm thinking about the horse betting and then going into baseball. That's fascinating. It reminds me of like the early days of that movie Moneyball, where they're starting to use statistics to make predictions in baseball.
Exactly. Yeah. And then they took those same statistical techniques. They used them for things like figuring out how long criminals' sentences should be in courts and a lot of other things.
What were some key things that, as you began to use statistics for and applying them to sports, things that maybe we never really used stats for in the past? I'm curious about some of the data that you began to analyze and things you were thinking about that would be useful to help make predictions when it came to horse races or even baseball.
Yeah, so with the horse racing, it was kind of interesting because back then there was a lot of money bet on horse races. I guess there still is today. And in New York, a lot of the people who bet on horse races bought numbers from a very well-known supplier of numbers named Lenny Ragozin. And what Lenny used to give them was for every horse in every race in the New York area, he would give each horse a number that represented essentially how fast the race was run, but taking into account the conditions, like whether the course was muddy and everything. And so we just put all that data into a regression system that predicted basically the next number, and a way of taking the predicted numbers and computing the actual odds, comparing the actual odds to the odds that were up on the board, and so bettors could figure out when they had an advantage. And it was actually pretty interesting. We actually went to the track several times and used the system, and we didn't make money on every race, but overall it was pretty good for about a year, and then pretty much there was a lot of competition. There were a lot of computer-based regression systems that were doing basically the same thing.
And then tell me about your move into baseball. What drew you from the horse races to baseball?
So it was actually my graduate school advisor was Bert Green, who wrote that natural language program about the 1959 baseball season. But my partner and I, who worked with me on the horse racing, we also did predict the outcome of the 1979 baseball season. So we looked at a lot of different stats, and we actually got the predictions published in the New York Post at the beginning of the season, and we predicted 3 out of the 4 playoff teams, and the Post wrote a nice article about us at the end of the season saying that it was quite amazing.
Yeah, that's super cool.
It was a lot of fun.
Yeah, that's super cool. As you look at the way stats and AI is being applied now to sports and kind of watching this whole evolution, I'm curious about the interesting trends you're seeing right now.
So, people are using a lot of the same basic techniques, but what's different now is that computers can handle a lot more data, and we have computational techniques like neural networks and especially deep learning neural networks that can compute much more powerful regression and classification functions than we were able to do, when was it, 40 something years ago.
Yeah, it's awesome that you've been in this field for so long and kind of watching the trends and seeing processing get faster and computers be able to handle a lot more data. What has led you now to write this brand new book?
So AI has made great strides from an engineering perspective. Siri answers our questions. Google Translate enables us to instantly translate foreign language web pages. Our smartphones automatically identify the faces in our photos, and self-driving cars even appear to be on the horizon. And all that progress naturally leads people to wonder, where will it all end? And many people are concerned that AI robots will become so smart that they try to exterminate us or turn us into pets or just take all our jobs. So in my book, I explain how AI works and why AI systems are not going to become intelligent enough to have the ability to exterminate us, turn us into pets, or take all our jobs. And kind of over the last 10 years, there's been a lot of hype about AI that inspired me to write the book. About 10 years ago, I don't know if you remember, but an IBM computer named Watson Deep QA beat 2 champions in Jeopardy on TV. And I'm a nerd. I was rooting for the computer, and it was pretty cool when it won and was able to answer very complex questions. But I knew from my background in natural language processing that under the hood it was all a lot of gimmicks. It was a very impressive result, but under the hood they were doing a lot of word matching of questions to documents stored in their memory and that sort of thing. And then IBM published a series of 12 technical articles that confirmed what I thought. But then IBM went on to rebrand itself around AI. It would start marketing itself as our Watson system thinks like a person and can read books and can do all these amazing things when none of that is really true. Microsoft had started doing the same thing. Microsoft Research created a program that for one tiny task did better on a reading task than humans. And so Microsoft started saying that our technology reads better than people. And then you have high-profile people like Elon Musk jump in, and Elon Musk started saying, and still does, is whatever chance he gets, that AI represents the biggest existential crisis for society, and that it could portend the end of the world. And then I had dinner with Roger Schank about 3 years ago, and we were talking about all these things, and he said, you should write a book. So I did.
That's awesome.
Wow, that is amazing. And just for those who aren't as familiar with artificial intelligence technology, What are some of the different machine learning algorithms? Can you just break them down, like before we go deeper in, for people who just aren't
Sure.
as familiar?
Sure. So AI is composed of two subdisciplines, machine learning and natural language processing. Machine learning has brought us the ability for smartphones to label the people in our photos, to translate web pages, self-driving cars, medical diagnosis, the horse racing program that I wrote, and much more. And these applications are the result of the most prominent type of machine learning, and that's termed supervised learning. Natural language processing has brought us the ability to converse with our smartphones and virtual customer service agents, and to analyze social media posts by computer. So those are the two main types, and again, the main subtype of machine learning is supervised learning.
I love that your book is, really getting into some of the fears that people have around AI, especially some of those hyped headlines that you see about robots taking over the world. I'm glad that you're addressing that. I'm curious about the fear of job losses. That's something that's been a huge concern. It's a practical concern. Obviously, automation and things like that have taken away jobs, but also we've seen that through automation, new jobs have developed. I'm curious if you can talk a little bit about the fears that people have around what they're hearing about AI and automation, and how some of these jobs will be removed, and what you see as potential.
Sure. So, I would say the fear of job loss is almost more of a myth than a reality. AI will take some jobs, but conventional software is going to take more jobs than AI. And let me just break that down. Conventional software is software that's created by programmers who write explicit instructions that computers follow, where in AI there's a bit of a learning component. And in my view, conventional software has been taking jobs for over 50 years now. You've got areas like e-commerce and word processing and many other areas where conventional software is responsible for job loss. But that said, we still haven't seen conventional software or any other type of automation make a big impact on the unemployment rate, because these automation technologies also create jobs. And AI is unlikely to take anywhere near as many jobs as conventional software. And the reason is that AI can only build these functions that perform very narrow tasks that can help somebody do their job, but in most cases, it's unlikely to take over their entire job.
So what would you say to those people who are extremely fearful, just to kind of put their mind at ease? Obviously your book dispels those myths.
So I think the best way to dispel a lot of the myths is to understand at a very high level how AI works. So let me explain briefly how machine learning works. Suppose you want to build a program to help diagnose a particular disease. You'd create a table of data in which each row in the table represents one person and has information about their medical record. Half the rows represent people who had the disease and half don't. And then the row for each person would contain features of the medical record, as I mentioned, that are important, like their age, whether they smoke, and so on. And then we would feed that table of data into a machine learning algorithm, and probably a supervised learning algorithm, that learns a function that can predict whether a person has the disease based on their medical record. And then once you have that function, you can take a medical record for a person who was not in that table of data and predict whether they have the disease. But the way it does that is it's learned a function. And just to explain, a function is just a formula. You probably remember learning formulas like the one that's used to convert centigrade temperature into Fahrenheit. You multiply the centigrade temperature by 9/5 and add 32 degrees. So is there any intelligence in that centigrade function? Absolutely not. And there's no more intelligence in the function that recognizes faces or translates languages than there is in the function that computes Fahrenheit temperatures. And more importantly, there's no way to take one of those functions and evolve it into real intelligence. So if we can't create real intelligence, and no one has really any idea today how to create real intelligence, then we're never going to have computers that can exterminate us, turn us into pets, or take all our jobs. So if you think about a computer that might take all our jobs, what are we really worried about? We can think of a computer or a robot that can read every book really quickly, can take every class, and if they can do that, they can take all our jobs. The problem is that reading books and taking classes requires real intelligence. We can't build that kind of real intelligence, so we're never going to have robots that can take all our jobs.
That makes it very clear. Thank you.
Steve, I think part of the fear also is not just job losses, and I think you expressed why that fear is kind of unfounded very, very well. But I think the other fear is around bias in algorithms and how those biases can hurt the results. So even though there isn't like an intelligence, it's merely a function, and here's the output. But sometimes if the input has been biased, the output can be biased, and that can in turn hurt people in various ways. I was sort of maybe kind of address the bias, because that is a fear, a justified fear.
Sure. So one area where you get really important type of bias is in facial recognition systems. So facial recognition systems are used to catch terrorists, criminals, even child traffickers. The problem with facial recognition systems is, and the National Institute of Standards and Technology published a report in 2019 where they evaluated 189 different facial recognition systems from 99 different companies. And they found that the systems were between 10 and 100 times more likely to falsely match a black or Asian face to a criminal image than a white face. So this is discriminatory, and it's led to innocent people being dragged from their homes and put in jail. And the issue isn't specific to facial recognition. You get the exact same issue with AI systems that make decisions on loan applications, hiring decisions, and criminal sentencing decisions, and many other decisions that affect people's lives.
Yeah, that's huge. Can you talk a little bit more about the criminal sentencing decisions? That's something you just mentioned earlier in the discussion.
Right. So, we talked earlier about Moneyball, how the Oakland A's had used statistical techniques, now called AI techniques, to figure out which players to draft and to build a Major League Baseball champion using, relatively low salaried players. The Attorney General of New Jersey, and I'm blanking out on her name, shortly after that said, maybe we should apply the same principles to criminal sentencing decisions. We have a lot of data about the people, and we have a lot of data about whether they, once we let them out, whether they commit crimes again. So why don't we apply the same idea to criminal sentencing, and the people who are more likely to commit crimes after we let them out, we'll just keep them in jail longer, and we'll use this AI algorithm to make recommendations to the judges on how long they should keep the criminals in jail. And they did this, and the problem with it is that in the historical databases that they used to compute these algorithms, people from poorer neighborhoods tended to get out of jail and be repeat offenders. So what these systems would do would be to learn, okay, so we'll just keep people from poorer neighborhoods in jail longer. And of course, that's completely discriminatory. That's just not a fair practice.
Yeah, and I think the trouble is that people are trying to use, mathematics and stats and AI to help make objective decisions. I mean, ultimately, that was kind of the goal. Let's try to remove the human element of discrimination and racism that might be there, and instead let's use math to help make these decisions to hopefully be more objective. But as you pointed out, when the input data might be biased in some way, then the AI is then making decisions based on that data. And to your point, it was then learning that, if you live in these specific districts, these zip codes, these areas, you're then more likely to reoffend. Therefore, you should have a longer sentence or whatever. It's a huge problem, because at the end of the day, we're trying to be objective, and that was really the goal.
Exactly. And, the thing people should remember about these systems, whether it's sentencing decision systems or facial recognition systems, is that for the most part, the people who create these systems aren't biased themselves. And even the learning algorithms that are used to create these systems aren't biased. What's biased is the data that's fed to the learning systems. So, for example, most facial recognition databases are composed primarily of white males. And as a result, facial recognition training produces systems that do well on white males, but that don't perform as well on people of color. And, you would think that would mean that these systems would catch fewer minority terrorists and criminals, and that is true. The problem is it also means that it will falsely accuse more innocent minority citizens.
Definitely. And as we are learning that these algorithms are biased, and as AI technology continues to advance, how can these algorithms become less biased over time? Is that a possibility?
Yeah, that's a great question. And the answer is the systems need to be retrained with unbiased data. In other words, if we're creating a system to recognize faces, the data can't just include faces of white males. It has to be diverse. The problem is it's harder than it sounds. So what do we mean by diverse? Do we need to have equal numbers? Do we need to have every possible minority represented? It's a difficult decision, and there's a lot of research going into it. And at this point in time, when it comes to facial recognition in the United States and in Europe, law enforcement is stopping the use of it in a lot of cases. There are bills pending in the U.S. Congress and in many state and local government legislatures to ban the use of facial recognition technology in law enforcement. The state of California has enacted a 3-year ban that started a year or two ago. There's a ban, a bill pending in the U.S. Congress to ban the use of facial recognition in public housing. And last year, some big companies, including Amazon, Microsoft, and IBM, all decided to suspend sales of facial recognition software to law enforcement agencies. And we're seeing a lot of regulatory activity in Europe and the US around discrimination in things like loan decisions and criminal sentencing decisions and other decisions made by AI systems that affect people.
Steve, what would be your advice for the data scientists listening in as they are working on AIs, as they're working on algorithms, and they want to reduce bias? They want to be very aware of the types of inputs, the data inputs going in, and the results of those inputs. I guess your advice for data scientists and data science teams as they're developing algorithms and AIs to help produce the best results with the least amount of bias.
Sure. Yeah, it's an issue for data scientists, and it's an issue for the companies that put out these algorithms. So for a long time, the focus was on how to take algorithms and build AI systems that made the best predictions. And all the big AI companies, there are a lot of companies that sell AI platform technology to do that, including big players like Microsoft, Amazon, Google, but a lot of private companies also. And that's where the focus was for many years. And now the focus is turning to making sure that systems are built with data that don't discriminate, and that the systems don't have biases. And not only just building them on a one-time basis, but monitoring them to make sure that they don't develop biases. And it's becoming very important for companies because of the regulatory activity. In some places, it is or it will soon be illegal. In the US, the Federal Trade Commission just put out a statement that says, look, if you train systems on biased data, you're liable for those decisions. It was a very, very powerful statement. And what you're finding now is that a lot of the new companies in AI that are developing technology is technology to help eliminate bias in the data and in the results, and monitoring the systems for bias in the data and the results. And I think I wrote an article recently, and I listed about 60 companies who are relatively new that are all involved in developing technology to reduce bias and to monitor for bias. So data scientists and the companies that employ them, should be looking to use those systems or develop their own. And companies need to be aware that they just can't put out these systems because they'll be liable for biased decisions. Not only legally liable, but they risk bad press. So very important for both data scientists and the companies who employ them.
Yeah, and I'm glad you're sharing all these recommendations. And so let's just say that a company and a team of data scientists are working on a new product. They're developing this algorithm, and they are sorting through all of the training data, looking for bias, trying to remove all of it, cleaning the data. Everything looks good. They begin to use it, and initially the data looks very successful, looks very useful and helpful. And you said something really important about monitoring the data, like going forward, and looking for bias later on down the line. So can you talk about what are some of the questions that teams need to be asking to help them in their monitoring process going forward?
Sure. What happens with machine learning systems is that initially they find data to plug into the algorithms to learn the functions, and that data is very similar to the data they'll encounter in the real world. But then what happens is that over time, the data they encounter in the real world changes. I mean, just as an example, in the last year, um, people are working at home. So a lot of the data that companies feed into the algorithms is going to be completely different because people are working at home, they're buying things online, they're not frequenting restaurants, and all the data that results from that is very different than it was a year ago. So it's important to monitor the output of the machine learning systems, both for how well they perform in terms of whether they make good predictions or not, but also in case the changes in the real world lead to bias.
Definitely. And you mentioned that there are laws and regulations being passed to ban the use of facial recognition in a lot of places. I would like to know, what are examples of ethical use of facial recognition, just to give us a deeper understanding of what that would look like.
Sure. So law enforcement I think is trying to use it ethically. I don't think law enforcement, for the most part, is trying to use it in a biased fashion. So if we want to catch terrorists coming in through our airports, and in fact, we're doing this at airports. Most of the airports are developing systems to catch terrorists by matching them up to using facial recognition. To me, that's an ethical use, as long as it's not discriminatory, as long as it's not the minorities that we stop accidentally and keep them from going on their vacations. The same thing with catching criminals. As long as the recognition systems are built with unbiased data, and we don't drag more minorities out of their homes than we do innocent people. And of course, we never want to drag innocent people out, so performance is also an issue. We really want these systems to be more accurate than they are today. But if we can do that without dragging innocent people out of their homes, and especially without dragging just innocent minorities out of their homes, then I think that's an ethical use. And of course, nobody's going to argue if we can catch child traffickers. The unethical uses of facial recognition are also interesting, and I think we're starting to see a stratification by country of how facial recognition is being used. So, for example, in China, there's and this gets more into privacy than discrimination, which is another one of those fears that are worth having. But in China, they're hooking up all the surveillance cameras in the country to centralized facial recognition software to monitor people, especially minorities. I mean, they've even used it to catch toilet paper thieves. So what's being developed in China is like a 1984 George Orwell Big Brother society. And I don't think that could happen in the United States. I think in the United States, and probably even more so in Europe, people are much more concerned about their privacy and would never allow governments to invade their privacy at that level. So we're seeing over time a stratification between authoritarian countries and democratic countries in the way technologies like facial recognition are being used.
I agree with what you're saying. And there's been far too many instances where technology has been used to identify certain suspects and it led to life being lost, and it was the wrong person. And this happens far too many times. And it's really unfortunate. And that's where that line gets blurred, where sometimes it's the ethical use in question that you mentioned, using that software to identify a possible terrorist or identify a sex offender, but it's the wrong person. And I just wonder if there's any deeper protocols that could be followed to make sure that law enforcement is not attacking the incorrect person and not just going off of, this is the criminal. But a lot of people, may not have an understanding of how these mistakes can possibly be made.
Absolutely. And I think what has to happen is when we go to roll out these technologies for something like using facial recognition to catch criminals, there has to be a performance aspect around it. So we have to know how many innocent people are going to get affected. In other words, if we catch 1,000 terrorists, does that mean we're going to detain, 100 people, innocent people from going on vacation, 10 people, or one person? And if we want to, we can use testing to figure out how well these systems perform. And at the same time, we need to test for discrimination, because if we decide that it's acceptable, to detain 10 innocent people in order to catch 1,000 terrorists, that's one thing. But if all 10 of those people are minorities, then that's just unacceptable. We can't have that. Or I think most people would agree we can't have that. So there are really two types of tests we need to do: performance and discrimination, before we roll these technologies out.
Yeah, that's like you're bringing up like such the complicated situation that we're in, because really the goal of this software is really to be objective, to find, in this case, the terrorist, to find the criminal, and to be objective about it. So we're removing human discrimination or human racism. We're letting the algorithm decide whether this person is truly that person or not. So the goal at the heart of it is really to be objective, to find the criminal and kind of remove the human potential racism or discrimination in the background, and let the bot decide. But you're bringing up like the complication with that.
Right. Yeah, and I think the answer is testing and public release of data about the testing, so that everybody knows the trade-off decisions that are being made by say the government. We're willing to detain 10 people in order to catch 1,000 terrorists, but that those 10 people can't just be minorities. We should know that.
Definitely. And what do you think that our motivation is for creating artificial intelligence? And are these motivations aligned with the best interest of humanity, like in the long term?
Yeah, so it's an interesting question, and I'm going to give you a historical perspective first. So in my book, I described 3 cycles of AI. The first cycle ran from the mid-50s to the end of the 60s. The second one ran from the mid-70s to the end of the 1980s. And in both cases, there was tremendous excitement and hype about AI, much like there is today. And in both cases, the cycles ended in AI winters, where there was little interest or funding for AI. For example, a Berkeley professor named Stuart Russell said he had 500 students in his AI class in 1985, but only 25 in 1990. And in both of those first 2 cycles, the goal of AI was to build intelligent computers and robots like C-3PO of Star Wars and the androids of Westworld. And today we term this idea artificial general intelligence. Both of those AI winters occurred because AI failed to produce anything useful and failed more generally to live up to its hype. If we had succeeded in building AGI systems, we'd be at risk of intelligent robots trying to exterminate us, turning us into pets, and taking all our jobs. And looking back, it's questionable whether the goal of AGI is in the best long-term interest of humanity. So in some ways, it's a good thing we failed in those first 2 cycles. We're now in this 3rd cycle of AI, but this cycle is very different. We're not trying to create truly intelligent robots. Instead, the focus has been on creating these individual functions that can perform amazing tasks like facial recognition and machine translation, but they have no intelligence. So in this cycle, we're looking at different fears and at issues like the ones we've been talking about, where we're interested in creating tools that benefit humanity, but there are certain risks. There are risks like discrimination, lack of privacy, and one we haven't talked about yet, which is safety, which is a really big issue. And I think it's fair to say that AI is aligned in the best interest of humanity as long as we control these issues like discrimination, privacy, safety, and the ability of AI to deceive us.
Yeah, I wanted to ask you about, you just mentioned safety. That's something we haven't covered. Can you talk a little bit about how you see AI being used for safety?
Sure. So, to me, the biggest safety issue we have around AI today is self-driving cars. So computers in self-driving cars are incredibly fast, they won't fall asleep, and they won't drive drunk. And therefore, many people reason that self-driving cars will, of course, be safer than human drivers. But that's a faulty assumption. Computers can't do one critical function that keeps human drivers safe. They can't think and reason. The computers in self-driving cars are made up of a lot of these functions. One recognizes pedestrians, another recognizes stop signs, but they can't think and reason. And most of us have encountered unexpected phenomena while driving. A flood makes the road difficult or impossible to navigate. A section of new asphalt has no lines. Black ice, drivers fishtailing, trying to get up a hill, or maybe they're drunk. And we all have stories. There are probably millions or billions of these different edge cases that we can handle as people because we can think and reason about them. We don't learn them in driving school. We use our common sense. If we hear an ice cream truck in a neighborhood, we know to look out for children running towards the truck. But no one knows how to build common sense into computers. Computers can be programmed to handle any of these specific situations, but they can't be programmed to handle all of them because there are millions and maybe billions of these edge cases. They'd have to be identified one by one and either programmed manually or given databases, big databases for each one of these to be learned by the machine learning system. So what we're doing from a regulatory perspective, the NHTSA, the National Highway and Transportation Safety Authority, has basically said, well, of course self-driving cars are going to be safer than people. So we're not going to try to create any special testing requirements before the manufacturers roll them out on our roads. And this scares the heck out of me. I mean, they can't think of reason. It just stands to reason that if we put them out and try to replace, say, consumer vehicles with self-driving cars, they'll have tons of accidents. I mean, I drive a Tesla, and I drive it maybe 90% of the time in self-driving mode. But I'm always ready to take over, and I take over quite a bit. And I would guess in the last year and a half, if I didn't take over when necessary, I'd have had 100 accidents. So it scares me that we're leaving it up to manufacturers to decide when to put these self-driving cars out on the road. I think the regulatory agencies should be developing testing protocols so that we can prove that they're safe and not just assume that they're safe.
Yes, I 100% agree. And what you were saying about these self-driving vehicles not having common sense like humans do, and then running into the arena of possibly having, these testing facilities that you mentioned. Do you think that with the progression of technology in general, do you think that we're headed for danger with the self-driving vehicles, or do you think if we were to have testing facilities for the vehicles, we could mitigate the risks and maybe lessen the fatalities that are going on right now. I've read many headlines of accidents with people, misusing the self-driving feature of their vehicle, and it could be a matter of maybe not using the technology correctly, or it could be these vehicles do not have common sense. So do you think we are headed more towards danger, or there could be a complete shift in the reliance?
I think we're headed towards danger, because today the manufacturers, even Tesla, say very clearly on their website that these are not Tesla uses the term full self-driving, which is a terrible term to be using, but they're not meant to be fully autonomous. You can't read a book while the car is driving you. Tesla makes that very clear on its website. But the manufacturers are looking to put out cars where you can read a book or watch a movie or not sit in the driver's seat. And to me, that's where the danger comes in. I believe we should be telling the manufacturers what types of tests they have to run to prove the cars are safe before they put them out on the road. And even there, I should qualify that. I wouldn't say that's true of every type of self-driving vehicle. For example, you can find self-driving vehicles in corporate parks that drive at 5 miles an hour, just from one point to another point. Those are completely safe. They have pedestrian recognition systems and animal recognition systems, and they're gonna reliably stop. And there aren't a lot of edge cases where you need to think and reason. So those are safe. And maybe vehicles that deliver packages you can do safely, and maybe even taxi service in limited parts of cities. But to replace consumer vehicles, it's going to be difficult. And I think even for taxi service, we should be requiring the manufacturers to prove that they're safe. And I should say, this isn't an impossible requirement. The data is there. The manufacturers that are testing driverless taxi services in Miami and San Francisco and Pittsburgh and other places, the way they're testing them is with safety drivers behind the wheel, ready to take over, and they record all the data every time the safety driver takes over. So why wouldn't the regulatory agencies say, well, you need to give me that disengagement data and let me determine whether your vehicle is safe to put on the road as a self-driving taxi or as a consumer vehicle?
Steve, before we go, I want to ask you about those data scientists, computer scientists listening in who are thinking about going to graduate school. And you went to Yale for your postdoctorate in AI. And I'm curious about your suggestions and advice for those who are looking to further their education in artificial intelligence and or computer science.
Sure. So you have great programs, the major universities that are doing AI, like Stanford and MIT and Carnegie Mellon, are all wonderful places. But interestingly enough, what's different today than 40 years ago? 40 years ago, all the interesting research was being done at universities. Today, a very high percentage of the interesting research is being done at big private companies, Google and Amazon and Facebook and Microsoft, OpenAI. So it's not just the education; it's the experience and the participation in some of these really in the development of some of these really interesting systems. So people can go both ways. You can go the academic route of getting degrees, or you can go the route of working in some of these really interesting corporate environments where you just learn a tremendous amount, and the people who are working in them today are developing expertise that's going to be invaluable for a long time to come.
That's excellent. Well, Steve, thank you so much for being on Data Talk. Before we go, can you share with everyone about your new book and how they can get it?
Sure. So you can find out all the book is available on all major retail sites like Amazon, but you can find information about the book, and there's a lot of other information about AI, including a blog and a free, very technical ebook on my website, and that's www.aiperspectives.com.
Fantastic. Well, Steve, thank you so much for being on Data Talk.
Yeah, this was fun. Thank you for having me.
Thank you so much for listening to this episode of the Data Talk podcast. We share new shows every week, and you can find the full catalog of previous episodes, including YouTube videos, on our Experian news blog. You can get access to the full catalog by going to experian.com/datatalk. And we always love hearing from our community, so if you have any comments or suggestions for future shows or guests you'd like to hear from, please let us know. You can leave a comment on iTunes, or you can reach out to us on Twitter @Experian Data Lab. You can also email me directly. My email is michael.delgado@experian.com. Take care, and we'll chat next week.